Hi, I'm Nathan.
And I'm Aaron, and with the help of our dad, we're going to show you how to put together the electronic dice.
If you look in the plastic bag here, you will see a number of different components. The first one we're going to look at is this little green board.
This is called the printed circuit board. All the other components will be placed onto it. The first thing that you'll notice is that there is a line on the board.
Don't forget to write your name next to the line on the circuit board.
I wonder how many people are going to write your name instead of actually writing their name.
We'll be using this to place some of the components. Let's call the part of the circuit board with the big hole in the top of it, the top of the circuit board, so we don't get confused.
In the bag, you'll see two black pieces of foam and two components stuck onto the foam. These are the first components we're going to use to put on the board.
These components are the integrated circuits, and you'll notice that on one side there's numbers on one piece and the other side it just has holes. The integrated circuit is basically the part that makes the entire project function. They can be easily damaged, so leave it in the piece of foam until you need it. The other thing that can damage these is that the legs on the integrated circuit can easily be bent.
Under the line, you'll see a whole bunch of little holes in parallel lines. This is where we're going to place the integrated circuit holders.
Notice that the two holders have different amount of legs on them. Now we are ready to solder.
When soldering, place the soldering iron onto the circuit board and touching the leg that you go to solder. Then count to 3.
1, 2, 3.
Place the solder in so it touches, and as soon as you get the puff of smoke, pull it away.
1, 2, 3.
Do another one.
1, 2, 3.
Sometimes what you'll find is that the solder gets caught to the printed circuit board. This is because you haven't pulled the soldering iron and the solder away fast enough. The way to get rid of this is just to reheat the solder with the soldering iron, and it pulls away. When soldering, it's really important to make sure you only put a little bit on, and it should only just be covering the circle where you're soldering. Try not to make it so that the solder goes from one component to another, otherwise your circuit won't work.
The next component is called the diode. If you look in the bag, you will notice 7 components all stuck together.
Don't pull them apart at the moment.
I wasn't going to. You will notice there is one that is exactly the same. This one is all by itself.
This one will be going over the black line with the little black strip facing the top of the circuit board with the little black hole, or the big black hole. You're going to need to bend it like so, then fit each of the pins or legs into the holes like that.
It's really important that you make sure that the black line goes towards the top of the circuit board, otherwise it won't work. And this first component should cover that line that's been put on the circuit board for you.
Think of it this way. What happens if a car goes down the road the wrong way?
Some amazing pictures here. Police in Philadelphia searching for an elderly woman caught on cell phone video driving the wrong way into oncoming traffic down a major interstate freeway. Her Buick Century wagon was doing about 80 kilometers an hour as cars and trucks were swerving to avoid her. At one point, the car hits the center barrier but keeps on going. The woman somehow was able to get off the freeway, but not before causing at least 4 accidents, including a truck smashing into a bridge overpass. Remarkably, there were no serious injuries.
Like cars on the road, components on your circuit board can get damaged. The diode will stop this damage.
Once you've soldered the legs into place, you can use wire cutters to cut excess wire off.
Okay, we're going to need 5 of these thingies.
They're diodes.
Yeah, whatever. We just need 5 of them. So, you can basically pull them out anyway, but then these are all going to go parallel to the first one.
Remember, it's important to make sure that the diodes all have the black strip facing the top of the circuit board, like we put into the first one. Yep.
The next component we'll need is called a capacitor. This is the piece of cardboard with the little blue knob at the ends. You can get this out by pretty much cutting the wires at the end of the cardboard like that. So whatever's in there you don't really need. All you need is this. Goes in between the 2 holes between the IC containers, like so.
The capacitor is like a storage tank. What it does is stores electricity, and once it is filled up, it then releases the electricity to the rest of the components.
Think of the capacitor as being like this Japanese bamboo water fountain. It fills with water, and once it's full, it releases all the water, ready to fill up again. Capacitor is similar. It fills with energy. Once it's full, it releases that energy, ready to fill up again.
Component we're going to use is called a resistor. As you notice, all the resistors have a different coloured lines on them. My dad will explain what a resistor is later.
I'll give you an example of what a resistor is. Now, a resistor is just something that slows down electricity. So imagine that I'm electricity and I'm trying to get from one point to another. So I've got a couple of boys to come up and help demonstrate what a resistor is. So we're going to start with the first person. We have a small resistor. So can you get you to put both hands out? Right, I'm electricity and I'm trying to get from one point to the other. So if I come up here, small resistor doesn't push very hard. So if I increase the size of the resistance, so I'm going to get the next resistor, both hands up and push. And you notice I need to push a little bit harder to get from one side to the other. And then lastly, if I get a larger resistor, stronger, if I push, and you'll notice here that it's really, really hard to push against the resistor.
Sergio was the example last time.
So what you'll notice is that different size resistors means that it can slow the electricity down depending on how big or how strong the resistor is.
Ready? We're looking for a resistor with brown, black and yellow in it. So if we look closely, you can see that these ones have brown, black and yellow on them. So we're going to do the same with the other ones. You just pull it off. And these are going to go right here, next, close to our circuit holder. So we're just going to
The next piece we'll need is another capacitor. You'll notice that it's different to the other one we have here, and it's got a black line on it. This will go above the in the 2 holes above the resistors that we just put in. When you put it in, you need to make sure that the black line goes to the right, remembering that this big hole here is the top.
Okay, we're going to need another resistor. This one is going to be orange, orange, orange right here with the lines. Not to be confused with the orange, orange, red or the red, red, red. So this one is going to go next to the capacitor here in these 2 holes there.
The next component we'll need to work on our electronic dice is called a transistor. It's the black little box with a flat side on one side and a curved side on the other with 3 little legs. When we put this down, it's going to go above the resistor here. So in these 3 little dots, 3 little holes that make up a triangle. When we put it in, we need to make sure that the flat side faces the top or the side that the big hole is on. The middle prong or leg, you're going to need to push away from the flat side in order to get it to fit into the hole. So you can just use a pen or something and push it back like so. Then just fit it into the hole. Make sure each of them goes in at roughly the same time, like that. We just push that down a little bit, like that.
I'm going to talk to you about the basics of a transistor. Really what a transistor is an electronic switch. Most transistors have 3 legs, and if you were to slice the transistor and have a look inside, basically what you'd see is some different component chemicals. And in the middle, this middle chemical is a semiconductor. So what happens is electricity can come in one leg and it wants to come out the other leg, but it can't pass through the middle because of this thing called a semiconductor. And a semiconductor basically means that it doesn't always conduct electricity. It does it on occasions. So if we were to hook up a circuit and electricity wants to come in one leg, and basically what happens, electricity goes up and then it stops. It doesn't go across the semiconductor. Now the way we get it to go across the semiconductor is if we run a current through this middle leg, it will enable a little change in the semiconductor to let electricity flow through. So if we let a small current go up into the semiconductor, a small current will come back out the other side. So this can reduce the amount of flow. If you put a big current in the small leg, the middle leg, the semiconductor will open up further and a larger current will actually go through. So basically what a transistor is a small electronic switch.